as you can see, it is beautifully, these are the three categories that I have highlighted here. These are the trends. Trends typically mean, is it increasing with time? Is it decreasing with time? As you can see, it says ice cream sales over time. Correlation means similarity. In English, correlation tends to mean similarity. A typical example of this is, this is just an example that I've taken here, ice cream sales versus temperature. Um, Ice cream sales versus temperature, just try to highlight, is there any similarity in the data? Is there any similarity that the lower the temperature, the more the sales? Because ice cream typically tastes best when the temperature is lesser, right? So it's just a very simple example. But another typically a more realistic example of correlation could be something that has been a part of research, which says that, all right, so the more the CO2, the more the CO2 as in carbon dioxide, the more the temperature. And this has been found to be a positive correlation. And what I mean to say by positive correlation, these are all data points. These are all individual data points, and you will see that they typically slope upwards. So what I'm doing here is I'm plotting individual data points. Please understand, this is my x-axis and this is my y-axis. And these are all individual data points. It could be something like 10, 20, or 1, 2, 3, 4, 5. The units could be anything, CO2, right? You could say ppm, parts per million, in whichever units you want to take it. And this could be Celsius. This could be 10 degrees, 20 degrees, 30 degrees, 40 degrees, and 50 degrees. And this is typically this is a typical coordinate plot where I'm saying each point here represents a particular value from my x-axis and a particular value from my y-axis. Okay, so in this case, it is like my x-axis is 3.5, my y-axis is 40 degrees, right? So this is how we typically plot a scatter plot. Okay, a scatter plot is what we represent two numerical variables. Why do I call them numerical variables? Because CO2 also represents a number, temperature also represents a number, and we use a scatter plot to represent something like this. Why does it tell us correlation? Because we can see that all these points are represented in this band. If you see, this is my band. If I have to quickly show you, if I have to quickly draw an outline around this band, it is somewhere around here. This is the band inside which all my individual data points are lying. And what can I say from this? This is again going back to maths, coordinate geometry basics. And we know that whenever I have a straight line, y equal to mx plus c. I don't want to get too much into the depth of coordinate geometry, but I just want to at least tell you that whenever you have a line that is sloping upwards, that is, whenever you have a line that is like this, sloping upwards, it is a positive slope. That means you have a positive correlation. And what do you mean by a positive correlation? Positive correlation means that when temperature increases, CO2 increases, or when CO2 increases, temperature increases. Okay, what is negative correlation? Negative correlation will look something like this. This is how negative correlation will look like. Okay, we call it a downward slope. This is what we call a downward slope, and it means that when one increases, the other increases, the other decreases. It's an inverse relationship, right? So the above one is a direct relationship where when one increases, the other increases, and here it is an inverse relationship where one increases, the other decreases. Okay, so that's positive correlation, that's negative correlation for you. So and the other is an outlier. We're going to look more about this again. Outlier also can be, if I can typically highlight an outlier here, it can be a point here. Let's say I have a point here which is coming somewhere around 6 in CO2 and somewhere around 10 degrees Celsius in temperature. Now very clearly you see all my points are lying here. This is the band where I have all my data points, but all of a sudden I have a point here. So that is called an outlier. Outlier is something which is out of place. Okay, so that's an outlier value, something that doesn't add up, something that is apart from the rest of the group, and something that is typically bad data. Okay, not always, but at times it is bad data, at times it is an error in the calculation, and sometimes it does tell you interesting things. So it might just happen that, okay, something is going wrong here. It might be some Arctic pole, North Pole, South Pole, whatever, and you want to take a deeper look into it. So outliers tell you interesting stories. Okay, there is something called discrete. Discrete again means number of employees in your office. Excellent example. So it can only be a finite number, right? It can be 1, it can be 2, it can be 3. It cannot be 3.5. You cannot have 3.5 employees in your office. right? Unlike continuous is the floating value. It is a real number. That's like rainfall in a year. So rainfall in a year can be 350.5 millimeters. It can be 3.777 centimeters, right? So continuous can be a decimal value, discrete is always a whole number value, and categorical is a qualitative value, right? And categorical can be further broken down into nominal and ordinal. We have already discussed this in greater detail, so I'm going to go ahead. So these are typical data relationships. If I have to briefly tap on this, a nominal comparison is typically a bar chart, right? So you're trying to compare against categories, right? So this is your simple bar chart. This is the same thing that we discussed here. You have different categories laid down here. Female, okay, female categories, there are so much is the number. Male category, so much is the number. And the number can be anything, right? The number can be sales, the number can be how many employees, can be what was the total number of purchases made. This number is usually represented on the y-axis, and it can mean anything. Okay, so that's a nominal comparison. Again, it is not getting too much into Spotfire specific at this stage. This is again a very general visual theory kind of session that we are having right now. So as you can see, it is a simple comparison of the quantitative values of the categories. All right, so if I have to plot something like number of visitors to various websites, obviously you can understand my various websites is going to come in my x-axis, and the number of visitors is going to come in my y-axis. If I have website A, website B, and website C, I'm going to have a bar chart with three categories. Okay, so time series again, typical trend line. Okay, we already discussed this. It's a line chart. You're trying to plot monthly sales. X-axis is your months, y-axis is your sales. Correlation, same thing we discussed here. This is correlation for you. Okay, scatter chart. Ranking, again, it is typically a bar chart. Okay, so what you see here is typically called a column chart. Why it is vertical? Again, we discussed this, that column charts are typically vertical, but in data visualization lingo, bar charts and column charts are two separate things. Bar charts are typically horizontal, so this is what we actually call a bar chart, and this is what we call a column chart. But in Spotfire terminology, they are both bar charts. If you see, if I come here, it is a bar chart, but you have to right click and you have to set. So these are the finer nuances, but in general, in visualization theory, we typically call the vertical ones as columns and the horizontal ones as bar charts. Okay, so that's ranking. You can actually show ranking. And why do I say ranking like this? Because it is easier on the eyes. The human brain perceives ranking easily when you've lay it out presently. As you can understand, we can see that females are higher. Now it is not that prominent when you have just two categories. So if you bring in a few more things here, it's going to start to make more sense. And if I have to quickly show that to you, let me see if I have some better data here. All right, let me get a stored location. This be better than. Let me remove this from my genders, from my colors. Okay, and now if you see, I'm going to quickly sort this for you. You have an option called sort bars by value, and now if you see, it is much more prominent. It is much more prominent to compare that which one is greater, just to give you a more visual appeal. Because the human brain, it's like thinking, as an analogy, it's like thinking you're running a race, and this is the finish line, and the other runner, New York, is just this much short of reaching the finish line. So it is just doing that visual comparison, rather than if I have to lay this side by side. If I give you a vertical bar, now you get the same picture, but somehow whenever you're doing ranking, a horizontal bar is much more prominent. That's what's being mentioned here. Ranking, you should always try to represent it using a bar chart, okay, which is a horizontal bar. A deviation again is something that you typically associate with histograms. We're gonna talk about histograms. So we briefly discussed about histograms here, and if I have to quickly go through this again, something that's mentioned here. So here, if you see, histogram is typically used to represent a number. Okay, how many categories are there in this particular bin? So first thing is, what is this? What is the shoes bins? If I have to quickly come here and show you, first thing is, let me show you the data here. The data here is Supreme, the Super Mega Mart, and let me come to my data table properties, and if you see here, sorry, if I come to my column properties, if I have to show you the column, and if I come down and show you what is shoes, this is my this is my this is the data table that I have, right? So basically what it's saying is it is grouping my shoes, it is grouping my shoes based on the different categories. Okay, so how many of them I have between 0 and 10, how many of them I had between 100 and 150, that way. So it is grouping it based on, if you see, if I just hover over, if I just hover over here, you'll see something called a tooltip that comes up, and it says that there are total 48 bins, and the X value here is between 93.32 to 99.79. So basically, not to get too much into the theory part of it, but basically it's a histogram. It typically is used to give me distribution of numerical variables. Like you can have a numerical variable like you can have something called weight, and you want to look at the distribution of weights in a class. Okay, you want to know how many people are from 0 to 10 kg, how many people are from 10 to 20 kilo, how many people are from 20 to 30 kilo. Okay, and if you plot that kind of a distribution, it will typically tend towards the normal distribution, right? Because so let's say this is 0, because there can be no one with negative weight, right? So that's why we start with 0 here. This is 10, this is 20, this is 30, this is 40, this is 50. So I know this is still pretty irrational, because I mean, obviously there'll be a weights which are like plus 70 for most, but just assuming that we are living in an ideal world where most people weigh 40 kilo, typically if you plot this as an histogram, you're gonna have something called a normal distribution. Okay, so most people will be weighing around 40. Again, it's an ideal scenario, because that's not the case. As I said, in an ideal scenario, let's assume most people in this world are weighing 40 kilos, and if you look at the extremes, 0 and plus 70, there are very little people. So most of the folks are in 40. And what have I done here? Again, these are bins, right? So is there a difference between this and this? Is there a difference between this and this? Actually, no. So how does it happen? If you increase the number of bins, substantially, you can actually plot a line over it. You can actually plot a trend over it. Okay, so this is where I have made the bins very, very small. So I'm looking at 0 to 1, I'm looking at 1 to 2, I'm looking at 2 to 3, 3 to 4, 4 to 5, and so on. Okay, I've made the bins very, very small, and I'm increasing the number of bins, and eventually I'm looking at the distribution. So most importantly, I'm looking at the distribution of a numerical variable uh, across a count axis. This is the count, how many people, and this tells you the weight. Okay, between this weight to this weight, how many people are there? So it gives you the distribution of a numerical variable. Okay, and that's exactly what's being mentioned here. You can actually, and this is how you can see, okay, how far any given data point differs from the mean. So what's happening here? So you can actually look at this particular point, the mean is 40, and it gives you an excellent idea that this class is symmetrically distributed around the mean. There are people who are weighing very high, there are people who are weighing very low, but most of my people are 40 kilos. Unlike a class which looks like this. And again, this is getting probably a little bit of stats theory, but you can get something like this. So this is the case. This is typically called a right skew distribution. So here you can see that there are people who are actually weighing 200 kilos, right? So you get a basic idea. Your mean is still here. Your mean is going to be here. This is typically called your median. Median means the middle point. Your mean is still here, and you get a rough idea of your deviation. How much more is your data point from the mean? Okay, so that's exactly what we are trying to look at by deviation. Distribution is something that we discussed already, and part 2 whole relationships are a pie chart, right? Pie charts are typically used to demonstrate what percentage of the whole. Is it only pie chart? Answer is no. We have already looked at it last. Real quick, I'm going to show you a few other details on the decks here, on different kinds of charts. The bar chart, okay, something we have discussed already. It's vertical, it's a horizontal. Okay, these are the two variations, and we already know what and when to use this. This is another variation. This is a stacked bar chart. This is the 100% stacked bar chart. So I'm going to proceed on this. So these are a few best practices that we follow for bar charts. You typically tend to use horizontal labels, and it makes sense, right? If you see here, the labels are horizontal. If I do a right click here, okay, you can actually set your labels. You can set how you are how you're aligning your charts. All right, so let me show this. Let me come to the Spotfire aspect later on. But what I'm trying to get at is uh, when you're displaying a bar chart, that means when you're displaying a column chart, to be specific, vertical, you should always display it like this. Unlike when you're doing it when I'm doing a horizontal, you should display it like this, and you can see how Spotfire automatically adjusts the properties based on that, right? You should not display it like this. How did you get this option? You can just do a right click here and you get this option of horizontal labels and vertical labels. Okay, and this gets a little tricky at times. You need to just drag and drop this up. If you see that, if you just hover over it, this is called the plot area. Whatever you see here is the plot area. So you can just actually bring it. You can collapse it. Okay, this is my legend. Whatever you see here is my column selectors. Okay, these are my column selectors. So if you just come up here, this is the title bar. Okay, what is the title bar? This is the title bar, right? I can opt to hide it. Come back here, show title bar. And one thing you have to remember is, it's again a few other Spotfire internals, that if you don't show the title bar, these mini selector options will not appear. Okay, so if you see, if I hide the title bar now, if I hide the title bar, no, I no longer see that option. To show the title bar, I need to come back to properties and I need to see show title bar. Okay, click on it and there's a legend. This is how you display the legend. There is one way to do it. What is the other way? This. If you see the tooltip, it says legend. This is another way, another shortcut to show and hide the legend. You can always do it from here. Okay, so I'll hide the legend. Category access selector is this. This is my category access. Okay, and what is my value access? This is my value access. So in a column chart, this is a category access and this is your value access. Okay, so I'm hiding it, and these are your scale labels. You're hiding your scale labels. If you see, there are no scale labels are appearing now. Okay, so obviously I will not do such a thing. I will of course display my scale labels, and you can of course control it individually from the value access. You can individually control it here. So if you only want to display for category access, you can show labels, hide labels. For value access, you can show labels, hide labels. But if you come here and scale labels, all the labels will go. Okay, so I'm going to go ahead and turn them on. There is something called a zoom slider, which I'm going to talk about a little later on. Okay, but there is an option for zoom slider which you can enable for category access or value access. Typically, we always do it for the value access for detailed comparison of the data. So I mean, so let's say you have data values which are very large. I mean, the scale is very large. Okay, it goes from 0 to 10 billion, and you want to do microscopic analysis of data. So you can actually use a zoom slider, and you can actually come back here and do a microscopic comparison. Okay, so now you can see your features becoming much more prominent. Is it making sense? As you can see, I'm doing a microscopic analysis of my data. Okay, so you can see how prominent these things become now. Okay. All right, so right, I agree, daytime is a good use case, but typically we also do it for values, as I'll show you a little later on my demos how you can represent it for values also. Okay, but we do it for values also. So there are two ways of doing it. So typically you will do it with date time, and in that case it will be a category access zoom sliders. In my category access, it will be a line chart. Very valid point. In my line chart, I will use it in my category access zoom slider. But there are use cases where I will use it for a value access also. Right. So in this case, I'm using it for a value access. I can also use it for a category access. As you can see here, I mean, it doesn't really make much difference if I use it in my category access, because I will not do that. It's a bar chart. I can see all the categories. I will not use the zoom slider. Makes no sense, right? But there are use cases for those kind of use cases of a line chart trend where you have date time values, where I will want to use it across a category axis. Okay. All right. So that's what I wanted to talk about some of these options here. There's a properties window that will come up if you hit this visualization properties, same as doing right clicking and clicking here, same option. And obviously if you click on this, that's close, and close means your visualization is gone basically. Okay, you're closing, that means closing in Spotfire means deleting. You can come back, you can undo it, and hitting close like this and doing right click and close mean one and the same thing. Okay, all right, moving on. The spacing bars appropriately. Obviously, there are a few standards that there should be 1/2 of the bar width. Again, not getting too much into the theory of it, but just remember that you got to space your bars properly, right? So it looks much neater here. Okay, it's got to start the y-axis at 0. Okay, this is a very important point. One of the reasons why, one of the examples that I want to show you is what happens if we don't do that. What happens if we don't start representing my um, y-axis at 0? What is the problem? So if you, as you can see here, if here I have a value which is starting at 50, okay, but the actual axis starts at 0, but you're only starting the representation at 50. So I'll tell you what the problem is. The problem here is, and something that you can already, I'm sure you can already visualize what the issue is. So the issue is, if you're starting from 50, and let's say you're 51, and you're 52, okay, and let's say you're 53, let's say you're 53 also, okay. So what you're doing here is you're representing, let's say these are rankings, okay. Let's say these are rankings, and there are 3 categories of cruise liners. Just an example, let's say there are 3 cruise liners, or let's say I'm not going to take any names right now. Let me take A, B, C. Let's say A cruise liner is this, B cruise liner is this, and C cruise liner is this. Okay, so these are my 3 categories of cruise liners, and I am comparing rankings of these cruise liners based on customer feedback and customer satisfaction. And as I'm seeing, C has the highest customer satisfaction. Okay, so obviously when you're trying to do marketing, if you're an employee of C, if you're the marketing head of C, you will want to show a bar chart like this. To be specific, you will want to show a column chart like this. Okay, because it really shows how outstanding your company C is, how big that bar is compared to the rest of the other, compared to your competitors. You're so high, right? So this is a typical case for misrepresenting data. Okay, are you telling a lie? Answer is no, because you are honest, you are representing your data correctly, but you are misguiding the audience. That would be the right word to put it. So what happens if we bring our bars close? So if this will be 1, this will be 10, this will be 20, okay, this is going to be 20, it's going to be 30, and somewhere here is going to be 50. Okay, and if the moment I do that, you will see all my bars will be roughly the same shape, because 50, 50, 51, 52, 53 will be all roughly the same shape. Okay, and all of a sudden, the story that the marketing head was initially trying to tell is no longer relevant for this kind of chart. Okay, so you can no longer go back to that client meeting, you can no longer go back to the internal sales presentation, and you can no longer boast about how good your C is. So again, it goes back to the initial slide where I wanted to talk about the story is very important. It really depends on the story that you're telling, and the story that you're telling in the second chart, representing starting at 0, is that, all right, so all the cruise liners are good, everyone fares well, but C does something additional, and C is just marginally better. So that's the story you're telling. C is marginally better. The story you're telling here when you're starting from 50 is very different. You're saying C is way better than the others. Okay, so that's what happens when you don't start your axis at 0. All right, so use consistent colors. This is something that we that we always recommend. One of the things here is, and one of the use cases behind that is, you see that use only one color for bar charts. So as you can see that they've used a red, blue, and a green here, but ideally I should represent all categories with the same color. And what is the argument behind it? If I come back to Spotfire again and show you, we come to a simple bar chart. So here I have Seattle, New York, Los Angeles, and Boston. They all convey the same information, right? They all convey the same information. They are all categories. I can already see their different categories. If I can already see their different categories, why do I need to do something like this? I will not want to do that, right? Colors are just another way to differentiate information. Colors are just another way to categorically segregate information. If I can already categorically segregate information using the different bars, then I don't need the colors to segregate information again, because it just confuses the audience, right? So this is a bad practice. We already know Seattle is an individual bar. We don't need to highlight Seattle with a different color. Okay, so we will not do that. A typical use case for using colors though will be when you are representing a separate legend. For instance, here the usage of colors makes sense, because if you see the legend information here has rural. So if I quickly show you the legend says rural, suburban, and urban. Okay, so here color will make sense because the category only represents a bar, and inside that bar you have to break it into three pieces, and how do you differentiate those pieces? That's where you're using colors. Okay, but when you're representing individual bars, you should not be using colors. Okay, and you have to order your data properly, obviously. Okay, apples, bananas, and oranges. And the way to do that, there are ways you can do that. Okay, and one of the things I wanted to show you here is you can go to column properties. Okay, and you will find something called a sort order here. Okay, so if you see here, this is my data. Edit column properties. This shows you all information about columns, right? The name, the column type, external name. This is the sort order. Okay, if I have to quickly come back here and show you. So these are my column properties. Okay, edit column properties, and as you can see, these are all the things I've imported. These are all the different columns I have. This is the data types of the columns. Okay, and a few other things you will find here. These are the formattings that you can set. And please understand, whenever you're setting formattings here, these are always set at a complete data layer. Okay, so this is the data table. Data table is this, and inside your data table you have these columns. Okay, these are all the columns that are present inside your data table. Okay, right, you see column properties, and these are your columns inside your data table. Right, typically you will get a drop down. If you have multiple data tables, you will get a drop down to select which data table properties you want to look at. Okay, but here, since you have only one data table, if you see here, I have only one data table here. Okay, that's why you don't get a drop down. So whenever you say column properties, you by default seeing all the columns that are present in that data table itself. Okay, so that's the idea of column properties. Okay, and formatting here is a report level formatting that you're setting. Okay, you can individually adjust formatting. So let's try to give you a quick example here. If you see sum of electronics, okay, if you want to change it, you can always come here. You can come to value access. Okay, you can always come to formatting here, and if you see value access, sum of electronics is the currency, right? And because it is a currency, you're seeing it like dollars. But you can always come up here and you can change it back to a general, or you can change it back to a number, and you will see the changes are instant. It is in preview mode. These are all instantaneous changes that happen. You go to a currency, you go to a number, whichever way you want to set it, it will come. Okay, but the thing I wanted to highlight to you is the difference between setting it at the visual layer, which is at the report layer, and setting it individually at the global layer. So this is the global layer. So if I have to go back to electronics, where is electronics? This is electronics. Okay, and I'm going to go ahead and set my formatting as the currency. Okay, that's my currency. So apply column formatting, hit apply, hit OK. All right. So this is how I will typically set my formatting. All right. So I'll bring it back to custom. Or you can set your custom number format. So, and you can do reset finally. Okay, when you do reset, basically the whole point of doing reset is that it will take from the default whatever you've set. So if you see here, edit column properties, this is the property, this is the formatting that you set at the global layer. Okay, so this is applicable in all your pages, in all your visualizations by default, right? So this is store location, these are all text, right? String are all text. Moment you look at integer, you get all these other options for integers, and the moment you get date, you get a lot of these other options for dates. Okay, how you want to represent the dates, right? I'm sure you'll be able to follow what I'm trying to say here. So this is how I've set currency here. If you see, it's the rupees that I've used, and that's why it's showing in rupees here. But what I wanted to highlight here was that when you come back to formatting, you can change it individually at the individual visualizations. Okay, so I can duplicate it here. I can duplicate the visualization here, and let me quickly go ahead and remove this vertical zoom slider. One of the things about a zoom slider is it does take up a lot of space. So I'll hit properties, and what I'm going to do right now is I'm going to show it something differently this time. Okay, let me show this the number. So what I want to show you here is that it's the same visualization. The global property was rupee for both. Okay, it was currency for both. but at the visual level, at the display level, I've just modified this one, so it is showing differently here. Okay, so that's the way you can change formatting options here. And coming back to sort order, something that we initially started with, going to column properties, you can go to properties. A few other things that you want can set here. It's not really relevant at this stage, but what is more important is sort order. Typically, customers will come back to you and tell you that, hey, I'm seeing Boston, Los Angeles, New York, and Seattle. I want you to set a different order type. Okay, so this is the standard sort order, and the standard sort order is the way you're setting it. Okay, for the data type means it means to say that that's your string data. So standard sort order will be your alphabetically ordered, right, A to Z. You can set your custom sort order. You can configure it, and you can say, you know what, I want to see Seattle on top. So you don't care about what order it is, and it's actually nothing. It means nothing if you see that Seattle is S, then B, then N, then L. It is not all ordered alphabetically, but it is something that you want your data to be sorted by. It's your custom sort order. You can configure it this way. Okay, move up, move down. You can configure it. Hit OK, and the moment you do that, you will see that it automatically reflects on all your visualizations. Okay, so Seattle will come first, then Boston, New York, and Los Angeles. If you see here, Seattle, Boston, New York, and Los Angeles. This reflects across all kinds of visuals, not just bar chart. Okay, and you will time to time see this other option which tells you apply sort order from another column. Okay, so this is another way you can do it. So probably you can go to store setting, and what you can do is you can apply your store setting sort order. So right now you're sorting store setting. It's already has a standard sort order. Okay, now you can set this from the column store location for store setting also. You can say apply sort order, and it will take the custom by default. So when you say apply sort order, it's not a very intelligent feature, but it just gives you a rough way of saying that, okay, if you've done sorting in descending order for some column, it'll automatically take that. But in this case, for custom sort order, it means nothing, because if you see here, I set a custom sort order, but it will try to set a custom sort order for this also, and by default, it will again take the alphabetical order, right? So I just wanted to show you this option, and you will also find the same option in formatting, right? So you would have formatted some other column. So for instance, in our case, we formatted electronics, right? Now what we want to do is, now we go back to furniture, and now we want to say furniture CPC by default represents as a number. What we want to do is we want to go back to furniture and say, hey, why don't you format furniture the same way that you formatted electronics? So if I hit apply formatting here, you will see automatically the formatting for furniture will be taken as per what we applied for electronics. Okay, as you can see, the data table is grayed out here because we are only dealing with one data table. That's why you don't get the option to select. And finally, one very important point to remember, something we tend to make a mistake as beginners, is that you need to hit apply after each and every changes. If you don't hit apply, if you hit cancel, and something I wanted to show you real quick, I cannot go back. If you hit cancel, you will see all of those changes that we did in sort order and all of that stuff, it got reverted. Okay, so you need to make sure that after every changes, especially in these edit data table connect properties and column properties, whatever changes you make, you need to make sure that you hit apply and hit OK. Okay, that's the basic flow that you should be following. All right, let me quickly come back here and let me quickly close this. This is fine. I believe this is okay, and this was the other. All right, so this was the other use case that I wanted to talk to you about, where you might need a horizontal slider. Okay, so this is an example where I'm showing you the sum of electronic sales in different store numbers. As you can understand, there are so many stores, and this is sorted by value. You can do right click, there's a sort by value option. If you don't sort it by value, the data is all muddled up. Okay, typically when you're trying to display information which is extremely detailed, especially information like this where you have store numbers and sum of sales, electronic sales, there are so many values of store numbers, right? And you can't possibly represent all of that in one axis. And this is a perfect use case for using a categorical zoom slider. Is this a category? It is a category, right? Because the store number is a category information, right? So I can actually use a zoom slider. I can come down here to my lower values, and I can see, okay, how much more is 53 compared to 22. So you can actually look at this information. Okay, 181.82 and 181.24. You can do the difference. So it's just used for very microscopic detail analysis. And if I had not used the zoom slider, you can just imagine that I would not be even seeing that value in the first place. Okay, so it's a beautiful way of comparing information which is pretty detailed. Okay, So that's a use case for your zoom slider, and this is another example that I've used for your bins. Okay, this is where you're using a customer age group for your bins. Okay, as you can see, you can do right click. We have used an auto bin column. Okay, Spotfire gives you a wonderful way to bin your columns automatically. If you come down to right click, and if you come to the category access, you can actually bin your columns automatically. If you see right now here, I have used auto bin. Okay, categorical data. This is all categorical data. All right. So you will see an option auto bin column. All right. You'll see an option for auto bin column. Okay, so there are cases when you might want to do it. Typically we will not set it like this, but again there will be cases when you might want to set it explicitly in this particular way that we mentioned. Okay, you might want to set it. You may not want to do it the usual way. If I just have to quickly show you, you need to go to column properties. You can insert, and there's something called a binned column, right? So you can set it explicitly, but Spotfire gives you a wonderful ability to set it automatically. Okay, so if you see that, just to show you right now, right, I'm gonna let me quickly talk about bin columns again. So bin columns is again to represent distribution of your data, right? If you see customer age is, if I don't use a bin column, so what will customer age give me? If I had to quickly do a duplicate visualization, and if I use something else, let's say if I use customer age like this, look at this data. Now if you look at this data, it's not conveying the right kind of information. Like I think a customer age is an excellent use case. So age is something which you don't want to represent as individual categories. You don't want to know how many people were 16 years old. If you look at the tooltip, it says, okay, how many people were 59 years old? How many people were 60 years old? Typically, we would want to look at ranges. So we will want to say, okay, between 55 to 60, how many people? Between 60 to 65, how many people? Between 65 to 70, how many people? So that is where you bin columns. So instead of taking each individual data point as a bar, if you see here, each individual age value is taken as a bar, I will group these bars together. So I will say, okay, between 70 to 80, I have so many people. Between 60 to 70, I have so many people. Between 50 to 60, I have so many people. That is where you bin columns, and this is how you do it. Spotfire gives you a nice feature. You can do right click and you can say auto bin column. That's how your columns get binned. Okay, this is how you can automatically bin your columns. The same thing that has been done here, auto bin column. Okay, just right click on that axis. To be specific, the category selector. Right click on that and you will see auto bin columns. Okay, you can set your number of bins here. So if you see, I have specifically set 5 bins. Can you select the range? You can select the range, absolutely, yes. You can do that. As I said, this is a Spotfire default property. The more finer and granular way to do it would be this. You can actually set a binned column here, and whatever you're talking about is something that you can do at a more granular level here. This is how you actually do it in projects. You'll get more granular control, but this is more of a Spotfire default functionality. And if you still want to set your bins, you can still do that. You can do right click. You can do right click, come to number of bins, and you can actually set your number of bins. If you want it to be more granular data, you can say I want 10 bins, and you get 10 bins. In the previous case, if you see, I have 5 bins. Okay, so something you can do here. So you can increase the number of bins, decrease the number of bins. You can either do right click, or you actually get a natural slider hierarchy here in Spotfire. Okay, right? So typically, again, in this kind of case, not to get too much into the formatting part, but typically we'll try to do it horizontal labels, right? Vertical labels. If we do it vertical labels, it's more prominently visible, right? So as you can see, between 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, right? All right, so that's a typical use case for using bins. That is a binned column. I hope it's making sense.